Alright everyone, I developed this project to teach you guys about object-oriented principles within the context of the verse programming language. It is my hope that with a better understanding of object-oriented principles, it will help you design your code to be much more robust, reusable, and less prone to error. So what is object-oriented programming and why is it important to us as game developers? Object-oriented programming is a programming paradigm that allows you to structure your code into classes, which you can think of as being like blueprints or a design upon which you can create many instances of objects. So imagine we have a factory that makes cars. The factory doesn't make just one type of car, it makes many different types of cars. Each one has a different design or blueprint. The design of the car isn't the car itself though, just like the architectural plans for a house isn't the house. The design contains all of the properties and perhaps behaviors of the thing it's designed to create. This is the class. From this we can create as many instances of the class as we like, just like cars coming off a production line. Each instance is a separate object with its own unique values for the properties it has. So for example, in your game, if your car gets a flat tire, only the one car gets the flat tire, not all of them. This is why object-oriented programming lends itself so nicely to games development, because we can create a design for something and spawn as many instances of that design as we want. What's more, we can take that design and make variations of it that share some of the characteristics of the original design. For instance, from our car class, we can create subclasses for, say, a muscle car, a sedan, a mini or an SUV, or whatever else we can think of. So let's take a look at this little project. It only serves to illustrate the object-oriented principles. We have 4 different animals tied to a different device, each a separate instance. They have 4 different buttons, which simply serve as ways to access the properties and behaviors of the objects themselves. Now, looking at one of these devices, just in case you want to recreate something similar to what I've got here, for this dog device, I have an instance of a dog being created for the device, and a bunch of strings. I'm of the opinion that if you're going to be using specific values or strings in your code, that it's best to have them declared in one spot. Because if you need to edit them, it makes them easier to find, and your code is less prone to error, especially if you're using the values in more than one place. We also have our buttons that are editable, so you can select them in the editor. Now on begin, I'm calling a constructor onDog. Normally you would call the constructor onDeclaration, but because of how devices work in verse, we can't call the constructor up here. I'm also setting the dog's fields using setters and subscribing methods to the button's events. Notice how a couple of them are tied to the dog object and are not device methods. So let's give this program a run and see this program in action. Starting with the cat goes meow once. All these buttons just display strings, by the way. She runs around chasing birds. She's a Siberian, and she's white. Our kitten also goes meow once, and what the kitten is actually doing is calling the same method as the cat, not its own. Don't worry, it'll make more sense when we take a look at the code in a bit. She runs around playing with a ball of yarn. She is a munchkin. And she's ginger. Our dog goes woof twice. He runs around the yard. He is a Rottweiler and is black. Our puppy goes yap 3 times, also runs around the yard like the dog, is a Shiba Inu, and is red and white. Here is a graphical representation of what we'll soon be looking at in verse. When creating a class, it is often a good idea to start with the interface. You can think of the interface as a contract or a promise to implement all of the methods contained within it in any class that implements the interface. So over here, we can see the interface just contains the definitions for the methods. So the names, as well as the return types, the type and number of the arguments being passed in, as well as the level of access those methods have. The interface doesn't concern itself with how the methods will be implemented. It's just a way of making sure that whatever class implements the interface, it follows the design that's been outlined. It can be very easy, especially when creating multiple classes or very big classes, to forget to include one or two things. Interfaces help us make sure that we include all the things that we need to. This becomes particularly important when multiple developers are working on different parts of the same project and are incorporating the same classes in their work. Now let's take a look at the first class in our hierarchy. Something to note is that it's been specified as abstract. This means you cannot create an instance of this class. Animal is too general or vague to create an instance of. But what makes abstract classes useful is that they can contain all the properties and behaviors that all animals have. This can save us a lot of time and unnecessary duplication when creating subclasses, because subclasses get everything the superclass it is inheriting from has. Inheritance is one of the principles of object-oriented programming. Now, if we take away the abstract specifier, you'll notice that we're getting errors. And if we hover over them, we can see that the class doesn't implement all the methods that's specified in the interface. So an abstract class doesn't need to implement everything in the interface, but any class that inherits from it must implement the remainder of the methods. Another thing to note is that a class can implement multiple interfaces. Now, if I add one of these other interfaces, we can see we're getting errors in all the classes below the animal class in the hierarchy. And that's because none of them implement the methods included in the newly added interface. So hopefully this illustrates how useful interfaces can be, particularly if you have a fairly dense class hierarchy. Now, before we move on, I want to talk about the other specifiers we're seeing here. First is the override specifier. This is something we need to use if we want to replace the functionality of a method that's already been implemented in a class higher in the hierarchy. This will make more sense when we take a look at subclasses, but because the interface itself is at the top of the hierarchy chain, in verse we need to use the override specifier when implementing the methods. The other is the private specifier. This is an access specifier which determines the level of access a field or method has. Where possible, we want to limit the level of access as much as possible, since this will reduce the chance of having errors in our code and make them easier to find when we get them. When a field or method is private, it can only be accessed within the current scope. So in the case of these fields, they can only be accessed within this class. To access them outside the class, we need to create public methods, commonly called getters and setters, to hide the data implementation. This is called encapsulation, another one of the object-oriented principles. Anything that is declared public has the least restriction placed upon it and can be accessed from anywhere. Other access specifiers you might see are protected, which means you can access it from within the current scope and any subscope, so for instance a superclass and any of its subclasses. There is also the internal specifier, which allows access within the current module only. This is actually the default in verse, so you might not see it being stated explicitly. Looking at our hierarchy, you can see that our animal class has two subclasses, cat and dog. Here we can see that cat inherits from the animal class. In this case, animal is the superclass, or parent class as you may hear it being called, and cat is the subclass, or child class. If we take a look at the kitten class, we see that it inherits from cat. Cat is the parent class to the kitten child class. Because the animal class is a superclass to the cat class, the kitten also inherits everything from animal. Now, unlike interfaces where a class can implement multiple of these, a subclass can only directly inherit from a single superclass. So if I try and add a second superclass here, we're going to get errors. Let's take a look at the dog class because it's been implemented slightly differently to the cat class and has a couple of extra things going on there. Up top, you'll notice that this class has a constructor. This means we can call makeDog like a function to create an instance of dog, instead of instantiating it using the class name. This constructor takes a string as an argument and assigns it to the internal field sound. Sound needs to be declared internal because the constructor resides outside of the class itself. Now, the class has the unique specifier. This allows instances of a class to be comparable using equals to or not equals to signs. This is thanks to Verse giving each instance a unique identity. Without this specifier, instances can only be compared for equality using their fields. Another specifier it has is concrete. Whenever a class is specified as concrete, it means all the fields in the class have to have default values. This is so it can be constructed with an empty archetype, and because of this, all subclasses will also be concrete. Next, I want to draw your attention to the makeSound method. This is a public method that calls a protected method called bark. Outside of the class, the internal implementation of makeSound is hidden and shows only what is relevant, that this method makes a sound. The fact that it calls a method, which runs a for loop and calls another method, remains unknown to anyone wanting to use the makeSound method. This is an example of the object-oriented principle of abstraction, where the internal implementation is abstracted away from the user. Abstraction helps reduce complexity when viewing a method. It helps increase security as only the important details are supplied to the user. It reduces code duplication and increases usability. And making changes or updates to the code requires less effort since the implementation is more isolated. Now, the last object-oriented principle I want to talk about is polymorphism, of which there are two kinds, static and dynamic. We can see the dog class has two methods with the same name, only they take a different number of arguments. This is an example of static polymorphism and is called method overloading. This is a form of early binding or compile time binding, so this happens when we build our code. In the puppy class, we are creating an override for the makeSound method. This is an example of dynamic polymorphism. It is a form of late binding or runtime binding and will occur while the game is being played. The way it works is, if we have an instance of a puppy that calls makeSound, it will use the implementation provided in the puppy class, not the one in the dog class. Now, if our puppy calls, say, getBreed, it will first look for it in the puppy class. Not finding it there, it will proceed to look for it in the dog class and keep going up the hierarchy until it finds an implementation in the animal class. And that covers the 4 principles of object-oriented programming. But before we finish up, I just want to go back to the puppy class and go over a few more specifiers you might see. The puppy class uses the final class specifier. This means that puppy cannot be a superclass and cannot have any subclasses inheriting from it. Other specifiers are public, which means instances of the class can be constructed anywhere, including outside of the module where the class is defined. And internal, meaning the class can only be constructed in the same module or submodules. We didn't really get into modules in this video, but you can think of them as being like portable containers which contain classes, data structures, and all manner of different things. You'll see these being included at the top of your verse files with the using command. Modules are a great way of keeping your code well organized and reusable across multiple projects. So now when you're creating your games and using Verse, have a go at keeping all of this in mind to write code that is more reusable, less prone to error, and easier to maintain. Hopefully you got something out of this video. If you did, please consider giving it a like and sharing it around so we can all become better game developers and grow together. I do have a few more videos in the works. One of them will kind of piggyback off the previous video where we created a health siphon mechanic. And in this one, we'll be creating a full ability/effects system that you can use as the basis for creating many different abilities and effects. If that sounds interesting to you, consider subscribing to this channel where there'll be more videos to come. Thanks everyone. See you next time.